Sans Takeuchi.
It was 2009. For Esther Sans Takeuchi, it was a high point of her career. The researcher was awarded the National Medal of Technology and Innovation.
It was a wonderful and amazing event. And in technology, that is the highest honor that is awarded in the United States.
Esther Sans Takeuchi is one of the most successful electrochemists in the USA. With 153 US patents to her name, she counts among the most prolific woman inventors in America. She became famous for an invention that today, for many people, means avoiding death in the nick of time, thanks to an unremarkable metal container no larger than a matchbox. Today, batteries like these are located inside most implantable defibrillators. And, in an emergency, they give an electric shock that saves the wearer's life. That's exactly what happened to Mirko Mölzner from Germany. He suffers from heart failure. His heart can suddenly stop functioning, leading to unconsciousness or even death. In 2008, doctors gave Mölzner an implantable defibrillator, and only a short while later, he suddenly needed it. I just finished showering after work, and I was heading to my locker when I suddenly fainted. And then the shock was triggered, just a few seconds or even milliseconds later. And then I got up on my feet again, and it was just as if nothing had happened. Every year, between 80 and 100,000 people die of sudden cardiac failure. The risk factors are heart insufficiency and arrhythmias. An implanted defibrillator can respond immediately, protecting such people. And yet, for a long time, such a device was not available. The right battery had still not been developed.
The challenge with the cardiac defibrillator battery was making it small, making it powerful, and making it last 5 years.
First, the battery of an implantable defibrillator should be extremely durable. Implanting a new one every year would be life-threatening due to the risk of surgery and infection. The second problem was the size. For external defibrillators to provide pulses of several amps, their battery has to be quite large. But for an implantable defibrillator, the battery size has to be reduced enormously. And finally, the biggest challenge is the strength of the electric current. Back in the late 1950s, doctors had already transplanted the first pacemakers. They spring into action whenever the heart beats too slow, too fast, or irregularly. For that, however, they only need a small amount of power, far less than a defibrillator.
The defibrillator battery must deliver 1 million times more power than a pacemaker battery. So we knew we needed a different battery. It could not be simply a pacemaker battery repeated 1 million times. It had to be a new chemistry.
It was a difficult task. But Esther Sans Takeuchi had an idea. She decided to build a battery made from lithium and silver vanadium oxide. Batteries with silver oxide were used in numerous household appliances during the 1960s. The 1970s marked the triumph of the lithium battery. Esther Sans Takeuchi combined both substances, adding a third one as well. For the anode, she used lithium. And for the cathode, the material silver vanadium oxide. Lithium is the ideal material for the anode. No other metal can provide more energy at the same volume. The problem was that conventional lithium batteries would not last long if discharged at over 2 amps in an implantable defibrillator. The new battery had to last up to 5 years and be relied on to discharge maybe a dozen times. Sans Takeuchi discovered that silver vanadium oxide could do exactly that.
The silver was important to provide conductivity to help in delivering power. The vanadium was important to provide long life and high voltage.
She had taken the first step. But now the new product had to be successfully marketed. Esther Sands Takeuchi's former employer relied on patents.
We were a small group, so we knew in order to remain competitive, we had to be clever. So we developed a strategic approach to patents where we obtained patents to cover the technology that we developed and patents to cover other possible solutions to solve the problem.
This marked the beginning of a success story. In 1987, Esther Sands Takeuchi's battery was implanted in a patient for the first time. Since then, her batteries have dominated the market for implantable cardiac defibrillators, which today is worth nearly $5 billion in the US alone, with more than 10,000 implants every month. But for Mirko Molzner, all of this is only of secondary importance. He knows that he owes his life to this technology, thanks to Esther Sands Takeuchi's battery.